Are there emerging research directions that focus on overcoming the inherent limitations of NaCrO2 for practical sodium-ion battery applications? How does the voltage plateau behavior of NaCrO2 compare to that of NaFeO2, and what implications does this have for battery design? What role does the crystal structure of NaCrO2 play in determining its phase transition properties and electrochemical stability? How does the oxidation state of chromium in NaCrO2 influence its ability to sustain reversible sodium-ion intercalation and deintercalation? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What experimental techniques are commonly used to study the phase transition evolution of NaCrO2, and what insights do they provide? How does the presence of oxygen vacancies affect the phase transition behavior and cycling stability of NaCrO2? What emerging research strategies focus on optimizing the phase transition properties of NaCrO2 for practical sodium-ion battery applications? How do the charge and discharge curves of NaCrO2 material at 25 mA G superscript 1 illustrate its electrochemical behavior over different cycles? What specific features in the charge-discharge profiles indicate the stability or instability of NaCrO2 during cycling? How does the voltage evolution during charge and discharge cycles reveal the underlying phase transitions in NaCrO2? What mechanisms contribute to capacity attenuation observed in NaCrO2 over multiple cycles? How does the initial specific capacity compare to the capacity retained after several cycles, and what factors drive this decline? Why does capacity fade become more pronounced with an increasing number of cycles, and what structural or chemical changes are responsible? How do the charge-discharge curves illustrate the relationship between sodium-ion intercalation and deintercalation processes? What role do voltage plateaus play in understanding the phase transitions occurring within NaCrO2? How does the presence of multiple voltage platforms indicate severe phase transitions, and why is this detrimental to cycling performance? What are the specific phase transition mechanisms occurring in NaCrO2 during charge and discharge cycles? How do these transitions affect sodium-ion diffusion and overall battery efficiency? What structural characteristics of NaCrO2 contribute to the observed voltage platforms? How does the evolution of the crystal structure during cycling impact its stability and specific capacity retention? In what ways does the interaction between sodium ions and chromium oxide layers influence the electrochemical behavior of NaCrO2? Are there external factors such as temperature, pressure, or electrolyte composition that accelerate phase transitions and further degrade cycle life? What strategies have been proposed to mitigate the negative impact of phase transitions in NaCrO2? What?